G'day, g'day, comrade subscribers. Hope you're all well. So, Tandy CoCo 2. So this is by no means a rare or exotic computer. Certainly more popular channels than mine have done far better videos on this machine than I could ever do. But let's see how we go. So this is actually an NTSC, this is actually a US model. So there's a couple of issues to get it to work here in Australia. I've actually had this for quite some time, and I just haven't got round to it yet. So, but yeah, so it's a US NTSC model. As you may know, the CoCo uses the 6809 processor, which is a little bit different to the Z80s and the 6502s we're used to. The 6809 wasn't too popular. It was apparently the more powerful of the 8-bit processors. I think it was Motorola's last kind of 8-bit iteration. And it was the most powerful, but it was a lot more expensive than the Z80 or the 6502. So that kind of hampered its appeal. And I think it came out at a time when 16-bit, it was partially 16-bit. I think it had a 16-bit data bus perhaps. But it came out at a time when the 8086 was coming out, 8088, 8086 was coming out. So obviously it couldn't really compete with those. But yeah, pretty nice computer. I've always wanted one. CoCo 3 is, I guess, the most desirable one because I think it's the most upgradable. But this one's in pretty good condition. So like I said, there's a few issues here in Australia. It's a let me just turn it over. So it's a as we can see here, that's the details. But the main issue, well, the first issue, is that it's a US power supply, 120 volt AC, which we'll see in here. See, I've already had it. I've had it apart for a long time. I just haven't got around to doing any videos on it. I thought it was about time. So yes, in this Faraday cage, we've got an iron core transformer. I could never find what the outputs were in the technical documentation. So I think it's roughly 8.3 volts. So we'll get the transformer out anyway. I think we've got a common, and then we've got 8.3 volts AC, 8.3 volts AC, which is then converted to DC. So that's the first hurdle. Yeah, you know, I've got a step down transformer, so I can use that. But ultimately, I'll be replacing that. The second hurdle is that it's UHF output only. Oh yeah, before I forget, so this came along with it as well. So I think this must be the original owner. It's don't worry, it's not a home address. It's a PO box. But Bonita Homes, April 16th, 1988. There we go, in what, Tennessee? So I guess that's where this one's come from. There's the board. As I said, so it's a 6809. So this is a 6809E, as you can see here. So the difference between the 6809 and the 6809E is that I think the E requires an external clock, whereas the 6809 has got an on-chip clock. I think that's the difference. 64K machine. Actually, we'll get to the video output in a minute. But I think it's a 64K machine, although I'm not too sure. So I need to check the documentation. So we've got a jumper J6 here, which I guess has an implication on the RAM size. Then we've got some jumpers over here. So the 128, so this is jumper 1. So it seems to indicate that maybe 128K. And then we've got these jumpers up here as well. Jumpers 5, or 2, 3, 4, 5, which also seem to indicate 128K. But when you actually look at the module, so this is the memory module here. Take it off, so just it's held down by some plastic standoffs there. Just there we go. So we have a look there. So these are actually, yeah, 64 kilobit chips. What is it? 8042665 or whatever it says there. So we've got 8. So these are actually, so that would seem to indicate that this is a 64 kilobyte machine. Yeah, not too worried about that at the moment. First thing I need to do is get the power working and get the video working. So if we have a bit more of a look, look around. Let's see, there's a few variations of the CoCo 2 as well, which complicates things when it comes to the video output. So you can see I've got my UHF modulator here, which is actually lying flat. I've seen other ones where the modulator can is on its end. So that, again, like I said, that complicates things. Like when you've got the spectrum and other things like that, you know, the composite mod is basically you've got a baseband video. You've already got the composite video signal being generated. You just need to modify it to output it to a modern screen. In this case here, we've got this, what is it, MC1372P. So this output, so this generates the RF modulated output video signal, but it doesn't take just a simple video or composite video in. It actually, we've got the data sheet here. It's got a colored two color inputs, and I think it's got a luma. It's got a luma input as well. Clock output, color luminance input, and color reference input. So I don't know about that. Chroma input and color difference inputs there. So we can see those. I'll grab a poker. So we can see those inputs here. So we've got our phi A, phi B, which I think is the color difference. Phi A, phi B. We've got Y there for luminance. So we can get a black and white signal, no problem. Yeah, but there are solutions, but I don't think there's any solution where I can just do it right now. So I'm going to have to order some boards. But there is one thing we can try. This chip, if you look at the data sheet, does have a way that you can get composite baseband output, composite video signal generation here. So I think it shows that it's where the RF tank input is. Yeah, this RF tank here, pins 13 and 14. So hopefully you can see that okay. A tuned circuit connected between these pins determine the RF oscillator frequency. The tuned circuit must provide a low DC resistance shunt. Applying a DC offset voltage between these pins result in a baseband composite video at the RF modulator output. So one simple way of doing that is to put a diode between the pins, I believe. So here we go. Does it actually show a diagram? No. So the RF modulator may be easily used as a composite video generator by replacing the RF oscillator tank circuit with a diode. Here we go, shown figure 3. That's figure 5. So it was figure, column here. Okay, test circuit 1 and 2. So there we go. It reckons this is all we need to do here, and we should get baseband video output there compared to RF output. So that'll be the first thing we try, I think. I don't think it's going to work too well. I don't think the quality's too good. So ultimately we want to replace that with something modern. But well, first of all, let's I'm not going to replace the power supply today, but I just want to figure out what the actual output voltages are. I do have some toroids that output 9 volts AC that would fit perfectly in here. well, not within the Faraday cage, but within the plastic surround. So let's hook it up and check what voltages we get. I just remembered before I do that, I was going to just turn it over to get the voltages, but we've got this metal thing, so we're going to have to remove this if we want to, for example, pull that out. So I'm guessing we just need to squeeze all these little metal pins here. So let's just disconnect the power actually. See how we go disconnecting. So it's a very nice board. Well, it's like the other ones. I think I do have a Dragon Data. We'll have a look at the Dragon Data in a minute. And also obviously I've got the Thomson machines as well. So I don't know. The best way of doing this is pushing it back through, maybe. Or levering it off. Maybe lever, whoop, okay, keep all those. Okay, that came off all right. Can I pull it off without squeezing it? No, I might, looks like I might need to squeeze it a little bit perhaps. Maybe, oh no, it's coming off. All right, I'll take this off. Okay. Don't tell the FCC. So what I wanted to do first is, where's the power input? Power input is up there. So just measure. Yeah, okay. So just measure the AC voltage in there. So I can replace the US transformer. Oh, those are a bit loose. Oh, okay, those are going to come off. Take them off so I don't lose them. Okay, plugged into the step-down transformer, turn it on. I heard a relay go, means it must be powered on. AC voltage, so that's the common. Doesn't really matter which way around it is, does it? So 8 volts. 8 volts, 7.9, so basically 8 volts in. So I think it was about 8.33 when it was unloaded. So it's about 8 volts. 8 volts AC. So I've got a toroid. Just power that off. Turn off there. So I do have a toroid. 15 volt amps. So this toroid will actually fit in place of this iron core transformer. It'll actually fit in there nicely. And then it's just a matter of that's AC in. Then what we've got, so orange, yellow, black and red. So orange and black, I think. Orange and black. So I think I'll wire it up. Let's just disconnect it again. Okay, so I think I'd wire it up. How would I wire it up? Oh no, you want the common, don't you? Okay. So I think orange black, yeah, I think orange black. So orange black will be the common, I think, and then we put red to red and then blue, yellow to blue, I think. I think that'll be the way I should wire it up. Anyway, we won't do that today. That'll be for later. We'll see if the machine works first. So to do that, what we need to do is first of all I want to take this modulator board off first. So you can see here the can is soldered in there, but then we've got these pin connections here. So I thought that might be the easiest way to, it's pin 13 and 14 we want to replace. Yeah, all right, let me try and get this out. I've got one of the tabs desoldered and turned back around. I just need to desolder that and that one. So you can see it's twisted. So I've just been using my soldering iron and also the desoldering sucker to heat it up and then basically get it to that state there so it's straight, so I can lever it out. With some effort, I'll have to replace, I think maybe, yeah, oh okay, no, that one's just come up a bit. Push that one back down again. So with some effort I got it out. So I assume, take off the bottom of the can and we can see what's going on with this pin 13 and 14. Okay, so it's a 14 pin chip, so pins 13 and 14 RF tanker up the top here, these two here. So there is, looks to be a diode there at the moment, but then it's obviously connected in with some other stuff here as well. So what do we want to do? I have tested, I have just plugged it straight into a composite input and yeah, it doesn't output anything. So it wants us to stick a diode and then 360 ohms up to 5 volts. So I guess that's where it is at the moment. Variable inductor, which yeah, oh, was that? I thought that was a capacitor. Sorry. Just trying to see what it's called. Diode 1. L1. Is that L1 there? Because that looks like a capacitor to me. Variable capacitor. Yeah, no variable inductors. Okay, variable inductor, variable capacitor, diode. So, alright, let me try and figure this out. How to modify this, because ultimately I'm going to be replacing this anyway, probably with a modern converter board. So I'm not too worried about this. I want to make the simplest change possible. Alright, 10 microfarad. Alright, so I might pull, see what's here. I might actually take a photo. Okay, so here we go. I've removed the parts that were connected to pins 13 and 14. So that's these ones here. So the parts that were connected are now removed. So there was, as you can see here, we had a diode, we had a variable capacitor, we've got a variable inductor, and a pair of resistors. So to do this composite modification, according to this, all we need is diode, anode. So this one's got the anode on pin 14. I think that's for inverting video. Let's have a look what the notes say again. Where was it? Oh, my feet are a bit cold. Cold today. Okay. So the polarity of the output waveform is controlled by the direction of the diode. So inverted video, anode is on pin 14, cathode to pin 13. Non-inverted video, anode to pin 13, cathode to pin 14. So I don't know if we've got inverted or non-inverted video. So I might go for non-inverted, shall I? Shall I put the anode on pin 13? So the opposite to this one here. So I'll put the so we've got the cathode on pin 13 here, so I'll put this the other way around. Then it's got a 360 ohm resistor to 5 volts. So 5 volts you can see is on pin 11. So that's the input voltage. So on this board here, a 5 volt input is this one here, plus B. So it comes in, goes through this ferrite bead, and then it goes along the top. So we can see here, so this is the 5 volts input pin, and you can see we've got the ferrite bead there. So we've got 5 volts going on this rail along the top here. So what I need to do apparently is just connect a diode, say between those two pins, pin 13 and 14, and then put a 360 ohm. I might follow this actually. I'll follow this because I'm not sure. So if I move the anodes over to here, then should I move the 360 ohm over to here as well? I'm assuming. Let's do it this way. Okay. So 360 to 5 volts, and I'm not going to touch that there. It says here we've got 2K. We can adjust the magnitude of the video output by adjusting, I guess. This says plus 7 volts, but I think I won't do anything for now. I think I'll just, where were we? I think I'll just put the diode in. So stick a diode into there, and on pin 14 here, then connect up to, just run a resistor up to here, I guess, or I could run it down to there, or I could drill a hole. Maybe I'll drill a little hole. No idea if it'll work. I probably won't, but we'll give it a try. Okay, there we go. So we basically, all I've done is add in diode. So cathode is on pin 13, anode is in on pin 14, and then I didn't have a 360 ohm, this is a 330 ohm, so that's just between pin 14 and 5 volts. So drill an extra hole there on the 5 volt rail. So we've got 330 ohms there, pin 14, and then we've got the diode here, anode, pin 14, cathode, pin 13. So I don't want to solder it back in, it doesn't work. So I am thinking I might just run some wires to it, plug them in perhaps, and then just run the wires from here, and we'll see what happens. Let's try and tidy up a bit, eh? Woohoo! I have an output. Pretty shithouse, but it's working. Alright, so what I've done is basically pin 12 is connected straight through. So pin 12 is the output here. Oops, sorry. So I've got it wired up this way, so that's for inverted video. So maybe I need to put the diode around the other way, in which case I guess I need to maybe move the resistor over to here. Here I've just connected pin 12 straight up to the video output. I haven't put this 2K resistor in yet. I was just going to put it to 5 volts. I don't know where 7 volts is. I don't know if we've got it on here. But that's just basically, yeah, so the computer's working. I wasn't expecting anything wonderful. Yeah, so that's the start. So I could probably, I'll try and improve that. Maybe I've got, like I said, I've got the diode around the wrong way between pin 13 and 14. So maybe it's non-inverted video, which is what I assumed it was. Yeah, so I'll do that. So that's where we are at the moment. So you can see that I've removed all those other. So let me just actually let me just show you what I've done. Okay, so on the modulator, what I have done is I've removed this resistor here. So I've had a look at pin 12. So pin 12 is the video output. Pin 12 is the video output, which is this pin here. So if you follow this pin up, you can see we had a resistor here. So I've removed that resistor. I think it went to there. And then we went down to here. So we had a, I think it was like a 3-pin kind of ceramic. So middle is ground, obviously. So video input here, then output here, and then we've got a couple of, we had a couple of resistors around here as well. So I removed those. So you can see here, I removed that 3-pin capacitor and these resistors around here. And I'll just put a link direct to the output. So that was, yeah, so this is the, I'm assuming it was the capacitor that I've removed. So let me just try and hold it. Sorry. Yeah, 3-legged thing. Anyway. So yes, so it is possible to get composite output. I say I might reverse this diode. In which case I probably need to move this resistor as well. The other thing obviously as well is that I don't, like I said, I don't have this 2K resistor to positive voltage, so that'll probably help as well. I'd need to, let's say that's the 5-volt rail there, so I'd need to run the resistor from here up to here. Drill another hole maybe. Anyway, so that works. So I don't like, I try to keep the videos short so you can kind of consume them in little bites. So we'll finish off with that now for tonight. I'm tired anyway. Went to Tamworth on the weekend for a night. That's good. Country music capital of Australia. It's only a 4-hour drive. Nice, quite nice drive as well actually. I'm going to upload those videos on my other channel. But before we go, let's have a look at the Dragon and the Dragon data and the Thomson MO5 and just compare the boards. So here is the Dragon. It's a big beast. It's actually compatible with, to a degree, with the CoCo. It's got the same expansion port, which is where I can use this same CoCo SDC it's called, SD interface. So that'll fit on here. It'll also fit on the CoCo. So there's a lot of, I'd say there's a lot of space in here. We'll open this up and we'll compare the boards. So here's the inside. Yeah, I've done some videos on these. Had some issues, I think, because of the tantalums. I think the tantalums probably blew. So I have replaced some of the capacitors on here. But looking at the board, so the CoCo 2 is definitely a smaller board. Let me just unplug the power. That's the Dragon. So 32K, 64K. You can see the CoCo is a much more compact board. I think, what have we got for the video processor? That's the video processor there, isn't it? XC80652. Whereas here we've got a genuine MC6847. Well, what I mean as genuine is that's what's designed to work with the, well, that's just got a normal modulator. That's some big bodge work. Did I do that bodge work or was that bodge work? I can't remember. So there we go, quick comparison. So a lot of space, a lot of space in here. Although actually when you look at it, they are basically the same size board, aren't they, really? You got the power, it's just got a bigger power supply here. This power supply is much more compact on the CoCo. But otherwise, you know, the boards are roughly the same size. Right, let's look at the Thomson. And here's the Thomson MO5, the Platini model with the neat little keyboard. You can tell just from the outside it's much more compact. Although the board, again, probably the board is the same size. Let's open it. I don't want to. I don't want to open it up, and I don't know if I actually opened this up. I don't know. Probably actually I haven't, because I have opened up the rubber keyed the original MO5. So the board is going to be the same. So that's why I haven't opened this one up. So this will be the first time opening this one up. Okay. Ah, that's right. We've got a gate array or whatever it is. Let's just disconnect the keyboard, shall we? So we don't break it. Well, it's feeling very, well, not very long. 1, 2. I think they're okay. I do like this keyboard. I do like it, I have to say. Right, so it's obviously quite different, the Thomson. We've got this big, it's not an ASIC, is it? Is it a gate array? You know, the equivalent. Basically, this does a lot of the handling. Got the RAM there, I guess. Let's bring it over the CoCo. So this is DC powered, so we don't have any AC on here. And actually, yeah, the CoCo is smaller. Although I think the MO5 is more advanced. I think it is more advanced. It's got 48K. Doesn't have as much memory, from what I remember. 48K. It is expandable. It does have a light pen. So, yeah, the MO5 is bigger board, but it's a more compact machine. There we go. Let me know if you need any more comparisons and I will do them. But I think that'll be it for tonight. So next we'll, I think, swap out the power supply. I'll replace the power supply with that toroid, and see if we can work on improving the video. I'll put this together later on. Okay, bye for now.